All right, our exam is coming up on Wednesday. It's February, I think it's the 6th, if I remember right. Let's get a check on that before I go saying that, though. Yeah, looks like the 6th. So there'll be an in-class exam for the in-class students, and then for the online students, you can come during the regular class exam, which will be from 3 to about 4:15, or if you wish, you can come. We'll all be there in the evening too, so if you want to come to Lynn Benton in the evening, you can take it then as well, probably about 6 to about 7:15. I'll put out a message on that here, a Moodle message kind of with the details. So I handed out a review, and you can get this in Moodle as well if you're online. So if you're online, it's in the test review downloads, the Midterm 1 review sheet, and then the review problems 1 and 2. Okay, so that's available there. So let's have a look. All right, the topics that could be on this exam are listed. They're pretty much the stuff that we've gone through today. So what we've got is a few things here. So we've got simple stress and strain, both for axial and shear. We've got this thing where you find internal forces and stresses when multiple forces are applied. So you can go ahead and basically find the reactions on an object, make a cut through wherever it is you want to find the internal forces, and then analyze one whole side of the object or the other. Okay, we've got stress-strain diagrams, which, as you might remember, looks something like that, with a straight line portion, and they flatten out and go up. So we got proportional limit, elastic limit, yield stress, and ultimate stress. Remember that you find the yield stress by picking a point here at 0.002 strain. So what we have here on this side is the stress, and then on this side is the strain. So the conventional way, or you might say the standard way to find the yield stress, is to find 0.002 on your graph, draw a parallel line up and intersect your curve, and then read the stress over on the stress axis. We have the ultimate stress, permanent set, yielding, and strain hardening. Okay. The modulus of rigidity is also called the shear modulus. That's G is what that is, okay? So that's the shear modulus. And that's similar to E for axial stress, okay? So the shear modulus is what that is G, okay? It's the shear stress over the shear strain. Okay, we looked at Poisson's ratio. Now what you have for Poisson's ratio is the negative of the ratio of the the lateral strain to the axial strain. So that's what Poisson's ratio is, okay? So Poisson's ratio, which is that Greek symbol nu, is what that is. And that's minus the lateral strain divided by the axial strain. Okay, then we did the axial deformation stuff, which is delta is PL over AE. And we did that when we had multiple forces applied to an object as well. We did statically indeterminate problems. You want to approach those by first recognizing that they're statically indeterminate, and then you write up as many statics equations as you can for the problem, and then also use delta equals PL over AE to work through that as well, and combine those together to solve for the forces and deformations eventually if you need to. Temperature-induced strain and stress, we covered that. Axial loading is the axially loaded bars, where we have those formulas for finding the stress, both axial stress and shear stress at an angle plane, I guess I should say. You can also find the maximum, minimum axial and shear stresses. And then we did the biaxial. We did a few different versions of that, finding the stress at some angle for a biaxially loaded element, finding the max and min stresses, which are called the principal stresses, and the maximum shear stress, and then using more circle and doing sketching. Okay, some of the vocabulary you might run into is shown down here. One thing to keep in mind is a lot of words here to represent delta. Delta is the deflection, deformation, and displacement. The way I remember that is all of those words begin with the letter D, and delta is a Greek letter D, so that's how I keep that in mind. So that's a bit of a run through of the topics that could be on the test. I also have some example problems off of old tests. We'll go over these on Monday, I think, if you like. So, or maybe Friday, I don't know, we'll figure it out. But here we go. Here's a stress strain curve. Find E. There's a system of shafts there that are loaded up. We want to find the deflection of point C after the loads are applied. Looks like you'll have to find some internal stresses when you do that, or forces anyway, when you do that. Here's a bar fitted snugly between fixed supports. The temperature goes up. I'd like you to find the normal and shear stresses in the bar. Here's a block with a load applied. Find the deformation, or how far point A moves after the load's applied. Okay, there's a tank on 3 posts. We want to find the force in the middle post, and also how much it deforms. So that looks kind of like a statically indeterminate problem to me. And then we've got some biaxial stuff. So there's a Morse circle example. That might be a good one to practice on a little bit. And then we've got, what else? We want to find the stress on plane AB, the normal stress. So a little biaxial work there, and then also sketch what it would look like if it failed. All right. Now, one thing I want to caution you on is don't just do the review problems and assume that's good. You should be looking at the homework problems and the examples we did in class to get ready for this test. Okay, so that'll be on Wednesday next week, February 6th.